Hi everyone, I am Dr. K. Assistant Professor in the Department of Civil Engineering at K.S.Rangasamy College of Technology, Trichangur. Today we will be exploring the properties of concrete in both fresh and hardened state. This is fundamental topic that bridges the gap between concrete production and its in-service performance. In this unit, we will cover fresh concrete focusing on workability, it influencing the factors and measurement methods. Hardened concrete strengthen properties including compressive, tensile, and flexure, as well as the stress strain behavior and modulus of elasticity. Hardened concrete durability properties such as water absorption, permeability, and acid resistance. Let's begin with the understanding how concrete behaves differently at various stages. Concrete behaves very difficult when it is fresh or plastic compared to when it is hardened. In the plastic stage, we call it green concrete. Key properties of fresh concrete includes workability, the ease of compacting without segregation or bleeding, segregation of coarse aggregate due to proper mix or improper handling, bleeding, water rising to the surface causing weak layers and pores. Harshness when concrete resisting finishing due to the poor grading at insufficient fineness. These properties greatly affects the final quality of hardened concrete. Uh, Once the concrete hardens, we evaluate it based on the strength, typically compressive strength measured on 150 cube at 28 days, M20 in the minimum grade for structural use. Resistance to wear, importance for pavement and industrial floors, dimensional changes including shrinkage and creep, durability, resistance to weathering, chemical, freezing and thawing. Impermeability, ability to resist water penetration, which is crucial for longevity. The water cement ratio is one of the most critical factor affecting concreting strength and durability. It is defined as the ratio of concrete of water to the weight of cement in the mix. A lower water cement ratio reduces porosity and increases strength, but it is too low. Workability suffers for proper hydration. About 38% of water by weight of cement. For example, water cement ratio is 0.38 is needed. In practice, we use water cement ratio between 0.4 to 0.6 to balance the strength and workability. It is also water cement ratio more than 0.6 porosity increases the strength decreases. Abraham's law established a fundamental relationship between the water cement ratio and the concrete strength. It states that the workable mix, the strength of concrete is inversely proportional to the water cement ratio. The equation is S equal to A divided by B to the power of X, where S is the strength of cement at 28 days and AB are constant, X is the water cement ratio. And according to the Abraham's law, the law highlights the controlling water cement ratio is key to achieving the desired strength. To ensure concrete is workable, we perform standard tests including slump cone test, compaction factor test, PB consistometer, Kelly ball test, um flow table test. These tests helps are quantifying and qualifying the workability and adjust the mix accordingly. First, we see the slump cone test. The slump cone test is the most widely used field test for workability. A conical mold, bottom diameter 20 top diameter is 100 and height is the 300 is filled with four layers, each rodded 25 times. This cone is lifted and the slump that decreases in height is measured. Types of slump, there is true slump, shear slump and collapse slump. If it is true slump, even subsidence and shear slump one side collapses and collapse concrete collapses completely. Slump value helps classifying workability from low to high strength. Um, Next is the compaction factor test. The compaction factor test is more precise and suitable for low to medium workable mixes. It measures the degree of compaction achieved under the standard conditions. The compaction factor is calculated as compaction factor is mass of partial compacted concrete divided by the mass of fully compacted concrete. The value ranges from 0.7 to 0.95 with higher values indicating the better workability. This test is ideal for lab use for but can not be applied for in the field. The VB consistometers measures workability in terms of time required in remold concreting under vibrations. A slump cone is filled and placed in a cylinder put on a vibrating table. The time, which is in terms of seconds, for the concrete to fully spread and fill the cylinder is recorded. This test is excellent for stiff and low workability mix and results the expressed VB degrees. This is all the pictorial representation for the flow table test. The flow table test is used for the high workability and flowing concrete. A standard cone is filled and lifted, and the flow table is jolted a specific number of times. The spread diameter is measured and the flow percentage is calculated. This test is particularly useful for the self-compaction concrete and pumped concrete mixtures. Uh, um, let's begin with the hardened concrete. So the most common strength is compressive strength testly for the cubes and cylinders in the 7 days. And in summary, fresh and concrete must be workable, cohesion, and free from the segregation and bleeding. Hardened concrete must be mean strength and durability requirement largely controlled by the water cement ratio. We have covered the essential properties of both fresh and hardened concrete along with the key test and the influences of the water cement ratio. I hope this session provides you the solid foundation for practical applications in the concrete technology. Thank you for your attention.